Alright, so the first thing we're going to do is here we have an exponential form. What we want to do is we want to switch the x and y. Here's what's important. So step one, switch x and y. But we want either the exponent or the log to be on the left side. So here we have y equals 2 to the x. When we flip the x and y, that gives us x equals 2y. We all agree with that? I want to put my 2y on the left side so that it equals, let me put my y more in the exponent.
So the log always goes on the left side no matter what?
Place it. You want your log or your exponent always on the left side. And the reason we're doing that is because when we are reading to put this in as a log, we've been doing, this is our base of our log. So if I want to solve this for y, I'm going to have log base 2, and then what goes on the inside? X equals y. And so if we put our log or our exponent on the left side, it's going to make it so that we can read it in that way.
How did you know there was a log there?
Because the inverse of an exponential function is always a log function.
So that's an exponential function right there, and then...
This is our exponential function, and this is its inverse, which is a log function.
So I thought the exponential was something like the log inverse.
Sometimes they can, and that's what we looked at yesterday with simplifying and finding the shortcuts with that.
I don't understand how you went from switching the x and the y like that to going all the way down there.
So, can I put an exponential function and write it as a log?
Yes.
Yes, how do I do that? If I have 2 to the x equals y, how do I write that as a log function?
Log equals y.
Not x. It's y equals x. So I took the inverse of my exponential function and I wrote it in log form. That's what I did there.
Then why is this x?
Oh my gosh,
So that's how you read that when you switch it from on day 1. That's what we worked on. The first day of notes. When we switch, this is our base of our log. This is what we equal. So if I have log base 2 of 16, 2 to what power gives us 16?
2 to y, or 2 to whatever x is.
So I think it's 3, right? So 2 to the third power equals 16.
Oh, so since you wrote log 2 y equals x, then you said that since it goes to that, it equals y.
You have to say that again. I'm trying to fix my mistake. Say that again for me.
So because log 2 of y equals x, that means log 2 of x equals y.
This is the form. So log base 2 of x equals y. This is the answer.
And then if you wrote this out first with a log right there, then you multiply the log 2 times x to get the y. Or
Yeah.
x to the power. Okay. Yeah. Okay.
I think so. Alright. So let's look at the first example here. So our first thing is to switch our x and y, and we're going to place the exponent on the left side. Alright, so now I need my exponent. This whole thing is going to go on the left side. So now I'm going to have 6y minus 3 equals x. I'm just flipping the spot. Alright, our goal is to make this y equal. So I need to move my 3. I need to get my exponent by itself. So I need that 6 to the y power all by itself. So we're going to add 3 to both sides. get so I'm gonna get 6y equals x plus 3. Now, we're gonna switch it. We started with an exponential function. The inverse of every exponential function is a log function. So we need to switch this to log form. So what's our base? 6.
Does an inverse,
So we're gonna have log base 6.
does an inverse give the same answer as a normal exponential function?
Inverse just means when you do a composite of a function and its inverse, it equals x. It just means they're opposite. So like if we were to graph the exponent function and its inverse in log form, if we fold it along the line xy, everything's going to match up.
Oh.
It just means that, like, if we were to take, let's find the inverse and then we can look at it. Alright, so then, if I'm switching it to log form, this is my base, this is my exponent, so this goes, or this is my answer, so it goes inside, so it's x plus 3 equals, and then I have my exponent outside. That's it, it's y equals, right? So then we're done. So now, if we were to put this equation, if we put log base 6 of x plus 3 in for x, everything should cancel out. If we were to do that composite. And essentially here, we have minus 3 plus 3, we have an exponent and a log, so everything cancels out. Let's go through and do this next one. Are we feeling kind of okay?
Yeah.
New but weird?
A little bit weird.
Alright, so first step, swap our x and y. So y becomes x. And now we have e to the y plus 3 minus 1. Now we want our exponent on the left side. Okay. Step 3, get our exponent by itself, so add 1. E to the y plus 3 equals x plus 1. Now we need to switch this to log form, because log is what undoes exponent. So log base e, what goes inside, and what does that equal? Okay, what's special about log at the base of e? Natural. Is y by itself? No, what's sitting next to the y? So how do we undo?
Natural log. Can a natural log also just be written as log and then the number? Or no, that's log base 10, never mind. Wait, but I thought log base 10 was a natural log.
No, common law.
Oh.
Better to ask questions than to not know. All right. Do you guys want to try this one on your own?
Sure.
All right. Try this.
I think I did it yesterday.
Thank you. should be
That is not a term.
When we take the project,
Not after this one.
so that's
They have to go.
I gave you a inquiry.
Oh, soft side.
What do you want to do? Black? Wait, no, what do you have right now?
All right. So what do we have for this one? Does anybody want to do it?
Logan.
All right. So tell me what to write.
X equals 10, Y minus 15. I just kind of want to do that, 10, Y minus 3.
And as you guys get more comfortable with these, yeah, you'll start scheduling.
And then,
Log base.
oh, but that is all
Log.
No, that's not common. Oh, wait. It's natural log.
Oh, yeah.
Plus.
And then,
The right 18 and the left 18, what's that?
yeah.
Alright, what do we have left on this page? Let's see. Now you erase this. I did, yeah. If you left it on that line. Alright, so the next one, find the inverse of each log function. So now we have log, and we want to, the inverse of log is an exponent. So we're going to do the same thing, except instead of switching it to log form, we're going to switch it to exponential form. Alright, so this first one, our first step is still switch the x and y. Step 2,
Same for log on the left side.
yep. Step 3 is to get the log all by itself. So if there's anything outside, like this one has a 7, we want to make sure that the log is all by itself.
How do you move y equals 5?
We can't, that's part of the log, that's inside the log.
Isn't it a log base of 3?
Oh, thank you. My eyesight's not the greatest. Sometimes I get. There, I can just make it a 3. Alright, so now, our log is all by itself for this one. So now we're going to switch it to exponential form. So looking at our log, what's our base of our exponent?
3.
3. So we're going to have 3 to what power? 3 to the x equals y plus 5. Or is it 3 base? So now, is y still not all by itself? So I have that 5 there, so what do I need to do to get y by itself? Subtract 5. So why do you get rid of the log? Because because the inverse operation of exponential is log. So we're finding the inverse and we get to be in that other form.
So you're basically just putting the x over.
You're just rewriting it, yeah. Alright. Let's do one more together and then you can do that last one on your own. Switch to exponential form and then get y by itself. Alright, so this one, step 1, step 2, flip them. We have our log on the left. So now we need to get log by itself. So right now we have this 7, we need to move it. And the reason we need the log to be by itself is so that we can do that switch to exponential form. So now what's special about this log? It's a common log. So what's the base on the common log? 10. So then the base on our exponent is going to be 10. So we're going to have 10. To what, let me get myself a minute. 10 to what power? Alright, so I'm going to have 10 to the xy. So 10, and this is my exponent, so x minus 7 equals 2y. Should I divide by 2? Now divide it by 2. Now don't divide the base. This is like our a, so it's our a that's in front, so if you can either leave it like that, just know that you're not going to take 10 divided by 2. So this is 1/2 times, so this is like the vertical stretch of 1/2 in that a spot when we did, remember when we did graphing of, just be real careful about that because we're not changing the base. Alright, so looking at this one, we have, do we want another one?
Yeah, this one is like
So we have 2 natural logs of x minus 1 plus 3, and then this is supposed to be equals y. Oh. Yeah, that is supposed to be equals y. Or, we're going to put the equal sign there, I assume that's supposed to be y. Alright, so step 1, switch x and y. So we're going to have 2 natural logs of y minus 1 plus 3 equals x. Place log on the left. We're already there. Now we want to get log by itself, so we're going to subtract 3. Alright, is natural log by itself yet? No. So we're going to divide by 2. Alright, what's special about natural logs? You want it colder or hotter?
Natural log.
No, I'll still think that.
Cold. I'll tell you what it is. You know what's special about it? It's very natural. It's a natural logarithmic.
Alright, so what makes it? It's a log with a base of
E. I knew that.
Alright, so now can we switch this to exponential form? Yes. So switching this to exponential form, we're going to have e to the x minus 3 over 2 equals y minus 1.
So you still swap the variables and then solve for it? Yeah.
So we need to get y by itself, so we're going to add 1 to both sides. Oh, I forgot my 1.
Yeah, that's what I was confused about.
Well, and I guess I was doing a visual check. I was mentally clicking that in to see if it worked out. Do we want to see the composite to see if it works?
Yeah.
Sure, that sounds like fun, right? Alright, so let's with this one, so we have 2 natural logs. So if we do the composite, we're going to make this our f of x, and this is our g of x. So in for x, we're going to put this mess. So e to the x minus 3 over 2 minus 1 plus 3. Alright, so now, wait, I forgot something. I forgot my plus 1 again. I'm like really getting on the 1. Plus 1 minus 1 plus 3. I'm checking it to make sure that if it's a composite, I should just have x left. Alright, what happens to my 1? They cancel. So now we have 2 natural log of e to the x minus 3 over 2 plus 3. Alright, so using power rule, I can put this into my exponent, right? So then we have natural log of x minus 3 over 2 times 2 plus 3. So now what happens to my 2's and my power? So now we have natural log of e to the x minus 3 plus 3. If this has a base that's same as my exponent, what are we left with? So I have x minus 3 plus 3, which equals x. So again, we're correct.
Wow.
Alright. That was a cool thing. So now, word problem. So the air pressure in a car tire is 44 pounds per inch squared. The pressure decreases gradually by about 1% for each trip of 50 miles driven. Write the equation for model P. The air pressure where x measures the number of 50-mile trips. Alright, so, you guys are driving, or almost driving. So, if you have a tire leak, are you adding or subtracting? You're subtracting it. So, what's the noise? Well, you know, trying to make it really. So this is really, it's minus 1%, right? We need to put that as a decimal. So what's 1% as a decimal?
0.01.
Right. And we have negative. Alright, so if a tire that's losing air, does it lose air in spurts, or is it a continuous leak? Continuous. So we're going to use the continuous. So that is A, E to the RC, where T is the number of trips 50 miles or over, or number of 50-mile trips. So how much pressure are we starting with? 44. E. What's our rate? How fast are we losing air? And T is the number of trips. So this is our equation. So now let's find the inverse of that. So how do we find the inverse? Well, do I have an X or a Y? Incorrect. So can we make an X and a Y?
Yes.
Yes. So insert T, what letter am I going to put? X. And our equation equals Y. So now we have an X and Y. What's step one of our step-by-step process? Switch them.
Why did you use the growth equation instead of the...
Because it's negative, so it makes it decay.
Oh, okay.
Alright, our goal is to get Y by itself. Our E is already on the left side. So what's our next step? Get log by itself. Is our exponent by itself yet? No. No. So let's divide that out. Right now, how do I switch? Right now in an exponential form, what's the inverse of exponent? Log. So I need to switch to log form. So what's the base of my log going to be? Natural log. So we're going to have natural log. And what's going to go inside my natural log?
The other side.
Right, this part, so x over 44. And what does it equal? And then we're going to divide to get y by itself. So y equals natural log of x over 44 divided by negative 0.01. And that's it. Just like that, right? Almost. Alright, so that's our work with inverse functions. Feelings on that?
I actually like that.
There is a pattern, there's 5 steps, whether you're going from exponential to log form, or log form to exponential form, finding the inverse. If you follow the 5 steps, then you'll be good. Alright, now we're going to do some graphing. Now, we're going to do this a little bit different. And it's going to seem tedious, but if we do all of the steps, life will be easy.
Is it the same thing as all of the other transformations?
No. But like I said, if you follow your steps, it'll make life easier. Okay? Alright, so let's do this column. We have y equals 2 to the x. So when x is negative 1, what do we have?
1.
What's 2 to the negative 1?
1/2.
1/2. 2 to the 0?
1.
And then 2 to the 1 power? 2. Now, what's special about inverses? If I flip the x and y, what am I doing with my columns? Flipping them. So I don't need to go through and redo it. I know that if x is 1/2, my y is negative 1. If x is 1, my y is 0. If x is 2, my y is 1. I just need to flip my columns.
Oh, you just switch them.
Just flip them, yeah. And so when we graph them, so this is my y equals 2 to the x. And then this column is in blue. Alright, and so we can kind of see that how these are reflections across the line y equals x, where we're flipping everything. So an exponential function had a horizontal asymptote. So for a log function, instead of horizontal, what kind of asymptote are we going to have? Vertical. Instead of exponential function had a domain that goes from negative infinity to positive infinity. A log function has a range that goes from negative infinity to positive infinity. Alright, so to get the graph for our log function, the first thing I'm going to do is I'm going to do a table for b to the x equals y. So when x is negative 1, b to the negative 1 power is 1 over b. B to the 0 power is 1, and b to the 1 power is b. So then, if I'm doing the inverse, then what am I going to do with my columns? Flip them. So this is going to be 1 over b, negative 1, 1, 0, and then b, 1. We have one for natural log. Again, I'm going to do a table. Since this has a base of e, I'm going to get e to the x equals y first, and get that column, and then just flip the table. So if I have e to the negative 1 is 1 over e, e to the 0 is 1, and e to the 1 is b. So now to get to the natural log of x, I'm just going to flip my table, my column. So I'm going to have 1 over e, negative 1, 1, 0, and e 1. So for all of these, we're actually going to do 3 tables. We're going to do one for the exponential one, and that's the one we have to think on. We're then going to flip the column to get the parent function for our log, and then we're going to do a transformation.
stop here, David.
No, we're gonna keep on going. I need to finish the video, so when you guys are working on this over the weekend, or Monday evening.
Recording all this time.
Alright, so what's our base here? What's our base? We have log base 2 of x, so our base is 2. So our table here, we're going to do 2 to the x equals y. So negative 1, 0, 1, we're not going to overcomplicate this. So 2 to the negative 1 power is 1/2. 2 to the 0 power is, and 2 to the 1 power is 2. Alright, over here, I'm going to flip that. Now, oh, you know what? And then we're done. This one, do we have any transformations going on here? No. So we're done. So let's graph it. So I have 1/2, negative 1, 1, 0, and then 2, 1. I almost hit all my points.
Oh, wow.
Alright, so what's my domain on this? Where is it approaching but never going to quite hit?
0.
Okay, so my vertical asymptote is at x equals 0. And that's this one here. I'm getting close to it, but we're never going to quite get there. So what's our domain? Horizontally, what's the lowest point we're going to go? 0. And then we're heading right, so we're going to go positive infinity. Range. Where's our range going? Everywhere.
Negative 50.
X-intercept, do we have an x-intercept?
1, 0.
Yep, 1, 0.
How did you even find the x?
It's a point on our table. Wait, what do you mean how I find the x?
Like the column of x's? How did you
Well, I found the exponential function, so I did negative 1, 0, 1.
So did you have to do that stuff that we were just doing on the other paper to find the exponential function?
No, I just plugged it into the equation. And then I just flip the columns because I know that the log function is the inverse. And so we just flip our x and y. Are we going to have a y-intercept?
Oh.
And then end behavior.
As
As x, what's x approaching?
0.
0. So as we get closer to 0, our graph is going down to negative infinity. And then as we get at the other end of our graph, as x approaches positive infinity, so as we go right, what direction is our graph going? Positive infinity. Alright, now we're going to look at this one. What is the base of this log?
1/2.
1/2. So our exponential function is also going to have a base of 1/2. So we're going to have 1/2 to the x power equals y. We're going to make this table so that for the log, all we have to do is flip our column. So what's 1/2 to the negative 1 power?
what?
What's 1/2 to the negative 1 power?
1.
What's it? No.
2.
2.
2. Yeah.
Alright, so again, 1/2 to 0 power,
1.
and then 1/2 to the 1 power, 1/2. So now we have our two columns here. What was our x column is now going to be our y column. So negative 1, 0, 1. And what was our y column is now going to be our x column. Lots of heads down. Lots of heads down.
We're all 3 feet.
I'm sorry.
Yeah. It's just a bad day, Mr. Chairman.
Sorry. Alright, so next my dot. Alright, so where's my vertical asymptote at for this one? 0. So unless we have a horizontal movement, it's always going to be at 0, or like a big horizontal stretch. Alright, so what's our domain for this? What's our furthest point left that we can go?
0.
0. And our furthest point right? Infinity, good. What about range? Are there any vertical limits up or down? No. X intercept.
Whatever, 0, 1.
Do we have a Y intercept?
1, 0, never, right?
I have think I have to.
Alright, end behavior.
As X approaches 0.
Alright, so we're going towards 0. What's our function? Is it heading up or down? And then as we move right, we're going towards positive infinity. So is this moving up or down?
Down.
Let's see, we'll fill in this and then we'll do one example on the back. Alright, so transformation. A, H, and K are all the same as they've been all year long.
A, vertical dilation, or flip, or the x-axis reflected.
Vertical dilation. If A is negative, then we have a vertical reflection. H is
towards the end.
horizontal shift, horizontal translation, and K.
Vertical.
Ladies. If A is negative. If negative A. We will do as many as you guys want me to do.
1, 0.
We're going to do at least one because we have homework problems. Do what? Alright, which one do you want to do?
Let's do a homework problem.
What's the next one? Which one would we do? Can we do like,
The one that's most second one.
First one.
What is the second one? That one has some stuff going on. Alright.
First one is like you.
The third one has everything going on.
Yes.
I feel like.
Third is the hardest, so yes.
I feel like second is really hard.
No, I feel like the fourth one's the hardest.
What?
Just pick one.
Alright, so let's do, we'll do the third one because that has a little bit of everything. The first thing I'm going to do is I want to do the transformations before we do anything else. So what are the transformations happening here? Logan.
It's going up one, going to the right one, or two,
it has a vertical,
Was that the fourth one?
has a vertical dilation, vertical dilation of 4. And then horizontal dilation of 3, right?
Right. So up 1, right 2, and a vertical dilation of 4.
Why you said that versatile? Why do we say
Alright, what is our base for this one? 1/3.
1/3.
Alright, so the first thing we're going to do is we are going to,
A whole bunch of tables.
we're going to make 3 tables. And so we're going to do 1/3 to the xy. So we're going to start with an exponent table first. So you're adding, because I'm doing this a little bit different, but it's going to make it easier on you. And we want easier, right?
Yes.
Alright, so we're going to start with -1, 0, 1. So not negative, 1/3 to the -1 power is 3. 1/3 to the 0 power is 1, and 1/3 to the 1 power is 1/3. Easy peasy.
Lemon squeeze.
Alright. So now what we're going to do is we are going to reflect that, and I'm going to put it in this table. So we're going to do the inverse. So what was in our y column is now in our x. Okay? Everyone still with me?
Yeah, that's.
Barely is still here. Alright, now, this is the tricky part. We are going to apply our transformation. And I am going to do my table over here for space reasons. Right. We are moving right to. So our x's, are they going to move to the right or to the left?
To the right.
So are we going to add 2 or subtract 2? We're going to add 2. So we're going to have x plus 2. So we're going to add 2 to all of our x coordinates here. So instead of 3, we're going to have 5. Instead of 1, we're going to have, instead of 1/3, we're going to have 2 and 1/3. Alright? Are we okay?
Good.
And then y is plus 1.
Alright, so now we're going to, and then, but then we also have that vertical dilation of 4, so we're going to have 4 times y plus 1. So our y here, so we're going to have 4 times -1 plus 1. -3. So we're going to have 4 times 0 plus 1 is 1. Here was our y, so we're going to have 4 times 1 plus 1. 5. Do you want me to write how I got these? The equation? Maybe?
No, that's
You don't have to, but just in case somebody... Oh wait, hold on. I did some bad math. This one's 5. Alright, so now we're going to plot these points. So we're going to have a point at 5, -3. So 5, -3. We're going to have a point at 3, 1. And we're going to have a point at 2 1/3, 5. So 2 1/3, 5. Now, based on just the transformations alone, if we move right to, what happens to our vertical asymptote?
It goes asymptote.
It goes right how many? So our asymptote should be at x equals 2. And if we check, that's exactly where it's at. Our range is always going to be, what's our domain?
2 and infinity.
Alright, where's our x-intercept? We'll have to guesstimate here a little bit.
Like 2 and 3 and like 2/3. Something like that.
Are we going to have an y-intercept? Are we ever going to cross the y-axis?
No, that is
Plus a 0. And then end behavior.
as x approaches 2, y will approach infinity.
So as we get closer to 2, where is our end of our line going?
Infinity.
Infinity. And as x approaches, so as we move to the right,
Infinity.
we're heading to negative infinity. Alright, how do you guys feel about that?
It's actually pretty
Yeah, we have 20 minutes left, so do you want to do another one, or do you want to start working on the homework?
Start working on homework.
We can check as we go, or if you want me to go over individually, we can do that too. I'm not sure where, I thought I was recording, but I wasn't really saying.